Hi everyone, we are going to review the material that was covered in 2-year Algebra 2 C, week 3, which covered SLT3 and SLT4. Both SLT3 and SLT4 examine the sine function. The sine function is a periodic function, meaning that it repeats over time. As you can see here, this is almost like a wave where it goes up and down, and values for y repeat over time. For example, the value of sine 45 is the same as the value of sine 135. Notice that the sine function is positive in the first two quadrants between 0 and 180, and is negative in quadrants 3 and 4 between 180 and 360. Now we're going to look at finding multiple values of sine. So here is an image using the unit circle, and we can look at here that the sine of 25 is 0.42. We know that because sine is opposite over hypotenuse, and the hypotenuse is 1, and so the sine of 25 is 0.42. If we were to have a triangle over here, we would know that the sine of 155, the angle starting here and going all the way over, would also be 0.42. If we had a triangle in the third quadrant with the angle of 25, that would be sine of 205, which would equal negative 0.42. And similarly, in the fourth quadrant, sine of 335 would also equal negative 0.42. If we went all the way around one circle and then back again, that would be sine of 385, which would be 0.42. In each of these examples, 25 degrees is considered a reference angle for all of these values of sine. So now we're going to explore some shifts in the sine graph. Here is your normal sine graph, where the maximum is 1 and the minimum is 1, and it's going on and on periodically. Now we're going to look at what happens if you change some of these values here. If there's a change in C, that's going to impact the midline. It's a little bit hard to see here, but C equals 2, and if you notice that the graph was moved up, so that the midline was 0, and now it's 2. The way to calculate the midline is high plus low divided by 2. And so in this case, it would be 3 plus 1 divided by 2 gives us a midline of 2. Changes in A impact the amplitude, which have to do with how high and how low. The amplitude is the distance from the highest point to the midline. So in this graph here, the amplitude is 2.3, going from 2.3 to 0. The midline did not change. Here and here, the midlines are both 0. Change in D in this equation has to do with a vertical shift. Here, there's no vertical shift. The midline is still 0. Here, we've shifted everything 40 degrees. Shifted everything 40 degrees to the right. And in addition, the midline is different. Notice the midline is 1 and not 0. So everything's moved up and moved over to the right 40 degrees. Finally, change in K, which impacts the period. Normally, the period is 360 degrees from high point to high point or low point to low point. But here, you look at when we change K, the period becomes 180 degrees. We can calculate the period by dividing 360 by K. Thank you so much for examining this video, looking at the material for week 3 of 2-year Algebra 2 C.